students. So in the last class we have seen some of the examples from the relation function, that is from the exercise 1.1. Some more examples we'll see from the same exercise. Okay. So here is the first question. So in the so far previous examples, the set A was given in the form of numbers like natural numbers, integers, or just simply 1, 2, 3, 4, 5, 6. Okay. But here the set is given in different form. So this set A is what? It is a set of human beings in a town at a particular time. Okay. So it is the set of what? Human beings. Okay. So under that set, these are the 5 examples. These are the 5 examples. So each example will discuss separately. Okay. See the first relation, R is equals to the ordered pair xy such that x and y work at the same place. So here, for that first example, we are going to check the reflexive, symmetric and transitive relation. Okay. So as I have written here, reflexive definition is what? Xx belongs to R. So when it is x, y ordered pair, what is the definition? X and y work at the same place. Now it is xx, it means what? X and x work at the same place, and it is true or no? Obviously it is true, because both are having same persons, they are not different persons. Okay, and their working place also what? Same. Therefore R is reflexive. R is reflexive. Now next, symmetric relation. Okay, what's the definition of symmetric? Xy belongs to R implies Yx belongs to R. So first what I will do, I will take only the first part, we'll check it whether it implies or no. Okay. So when it is xy belongs to R, it means what? X and y work at the same place. Okay. Suppose now this is the place. This is the place. So this x and y working in this place. Working in this place. Now suppose if I say y and x, then is their working places changed? No, working places remain same. Therefore this implies y and x also, okay, work at the same place. Okay, y and x also work at the same place. So when y and x is working at the same place means what? Yx belongs to R. Yx belongs to R. So therefore what? Xy belongs to R implies Yx belongs to R. It means what? It means what? The given relation is symmetric. The given relation is symmetric. Third one, transitive. So for transitive, we require the two ordered pairs. What? Xy belongs to R and Yz belongs to R. And Yz belongs to R. Okay. Now we have to check whether it implies Xz or no. Okay. Now see here. So this implies Xy belongs to R. It means what? X and Y work at the same place. I have written in short. X and Y work at the same place. Okay. And Yz means what? Y and Z work at the same place. Now take again example here. Okay. So this is your place. This X and Y work at the same place, and X and Y working in this place. So whatever the place working in the means where the Y is working, so obviously Z also will be working at the same place. Okay. Now see, X and Y working in this place, Y and Z also working in the same place. And what about XZ? XZ also working at the same place. So this implies X and Z also work at the same place. So it means what? XZ belongs to R. So therefore XY belongs to R, YZ belongs to R implies XZ belongs to R. Therefore R is what? Transitive. So hence R is reflexive, symmetric and transitive. Hence the given relation is what? Equivalence. Given relation is equivalence. Okay. Now take the second relation. So this will be for homework for you. See, X and Y live in the same locality. So what we have done with the solution, same solution you have to copy it. Okay, just what? Instead of working at the same place, You have to change the sentence is what? Live in the same locality. Okay, that is for homework part. Third one. R is equals to xy such that x is exactly 7 centimeter taller than y. Okay. Now x is exactly 7 centimeter taller than y means what? X height is greater than y. X height is greater than y. Means simply what? X is greater than y. X is greater than y. Now I just discuss the solutions. You have to write the solution for that. Now see, if I take a reflexive. If I take reflexive definition is what? X belongs to R. Now X belongs to R means what? That is X height is exactly, okay. Now X belongs to R means what we get? X is exactly 7 centimeter taller than X. Is it true? No, because we can't compare our height or weight to itself. We have to compare with other one. So therefore X cannot be 7 centimeter taller than itself is the answer. So therefore what? R is not reflexive. R is not reflexive. Okay. What about next one now? Symmetric relation. What is symmetric relation definition? XY belongs to R implies YX belongs to R. Okay. Now first order pair is XY belongs to R. Now XY belongs to R means what? X is exactly 7 centimeter taller than Y. Means what? X is exactly 7 centimeter taller than Y. So here X is greater than Y. Okay. But for the symmetric relation, reverse also true. But if you take reverse now, here what the symmetric relation says? Y also belongs to R. But if I use this statement, what will get? Y is exactly 7 centimeter taller than X, which is false. Why? Because here already we have said X is greater than Y. Then you can't say that Y is greater than X. If you say Y is less than X, that will be possible. But Y is greater than X is not possible. So therefore, for that example, Yx does not belongs to R. So therefore, what? For this third example, R is not symmetric. R is not symmetric. Okay. Now, for this relation, you check the transitivity. What the transitivity says? XY belongs to R and YZ belongs to R. That should imply XZ. Okay. We'll check it. Now, XY belongs to R means what? X is exactly 7 centimeter taller than Y. So X is greater than Y. And YZ belongs to R means what? Again, Y is greater than Z by how much? 7 centimeter. Then what should implies XZ? What should implies XZ? To implies XZ, see here it is 7 centimeter, here it is 7 centimeter. So X is greater than Z. This is possible, but how much it is? 14 centimeter. It becomes what? 14 centimeter, which is not possible because our relation is what? For 7 centimeter. But here we are getting 14 centimeter. Therefore, it is not transitive. Therefore, it is what? Not transitive. So hence, this third example or third relation is what? It is neither reflexive nor symmetric nor transitive. Okay. Next example. That is fourth one. Okay. This is very interesting. R is equals to xy such that x is wife of y. X is wife of y. Okay. Let us see now. Even this also I'll just discuss the solution. You have to note it. X is the wife of y. Okay. Now suppose if I take the reflexive relation, x belongs to R. It means what? As per the definition, if I take x, so you have to read as what? X is wife of x, which is possible. Okay. X cannot be the wife of x. X cannot be the wife of x. So therefore, what? R is not reflexive. Simple it is. Okay. Now for the same relation, if you check symmetric, what the symmetric relation says? XY belongs to R. Now XY belongs to R means what? X is wife of Y. X is wife of Y. Okay. But whether it true reversely it is true? No. Because here X is wife of Y. So X is a wife. But Y is what here? Husband. Okay. But if I say reverse, Y is wife of X, which is not possible. Which is not possible. Means it does not imply Y belongs to R. Therefore, what? For this fourth relation, R is not symmetric. Okay. Then check transitivity for this. Okay. If I check the transitivity, What the transitive relation says, xy belongs to R, yz belongs to R. Okay, let us check now. Now xy belongs to R means what? Here x is wife of y. X is the wife of y. Okay, and so here if you see y is husband here. Y is what? Husband. But in the transitive relation, you have to take one more ordered pair. Yz belongs to R. But if I take yz belongs to R, but what I should write? Y is wife of z. Y is wife of z, which is not possible. Why? Because you are already y is husband, but here we are considering what? Wife. So therefore, this second case is not possible. Okay, means this yz belongs to R is not possible. But to check the transitivity, we must have the two ordered pairs which is present in R. Suppose among that two ordered pairs means xy and yz, if any one also not possible, then we have to conclude R is transitive. We have to conclude R is transitive. Okay, because I have given one of the example to you people, right? That thief example. Okay, judge and thief example. Suppose if you don't have the proof, so it is better to say that person is not a thief. Okay, means that person will not be punishable until and unless you don't have the proof to say that he is a thief, right? The same example here. Now you don't have this yz towards you people to say that it is not transitive. So in that case, it is better to say what? It is transitive. So for this relation, R is what? Transitive. So hence R is neither reflexive nor symmetric but transitive. Similarly, for this fifth relation, you have to work out. It is same as x is the wife of y, right? So in the same way, you just do the answer for this. X is what? Father of y. Okay. I hope you have understood this examples. Okay. You just write the solutions first. Okay. I will send you the notes of the same examples. Okay. Thank you.